This video is on probability with Venn diagrams with a focus on conditional probability. So I'm going to start from the very beginning with Venn diagrams with a description of a scenario, which we're then going to draw a Venn diagram for, and then convert it into a Venn diagram for probability. So my question is this. In a group of 20 girls, 14 play hockey, 8 play camogie, 2 play neither sport. Draw a Venn diagram to represent this information. So pause the video here and give this a shot yourselves, and then in a moment unpause and see if you were correct. So I'm going to start by filling in the 2 that play neither sport. And that brings me down to 18 girls that I still have to fill into the diagram. But if I look at the numbers for hockey and camogie, so the cardinal number of H, which is 14, and the cardinal number of C, which is 8, well, they total 22, which seems to be a bit too much to fit into the Venn diagram. Don't forget, I can just subtract the total that I'm allowed, and that lets me know what to put in the intersection. So I'll fill 4 in here. I know the hockey set allows 14 in total. I've got 4 filled in, so I need 10 more. I know the camogie set allows 8 in total. I've got 4 filled in, I need 4 more. And now my basic Venn is complete. Next, I want to draw a Venn to represent these values as probabilities. Well, I note that the cardinal number of my universal set is 20. So what I'm going to do is take each of my individual cardinal numbers in my original Venn diagram and put them over 20 to get the probabilities. And I can write these as fractions or as decimals. And it's probably a little bit neater to use decimals when filling it into the Venn diagram. So we'll go now and we'll redraw our Venn and put those values in as the probabilities instead of the cardinal numbers. So I'm putting 0.1 on the outside, 0.2, 0.2, and 0.5. And one feature that I should always spot is that when I have my whole universal set completed, the probabilities within it should sum to 1. The probability of one of those events occurring is 1. So let's find some individual probabilities now. First of all, let's find the probability of H. Well, the probability of H in this context is the probability of choosing a girl that plays hockey. Well, you can see that the H set contains 2 regions, 0.5 and 0.2. Together they make up the total for H. So the probability of choosing a girl in the H set is 0.7. Find the probability of H intersection C. Another way of phrasing this is to find the probability of somebody playing hockey and camogie. And that's this region here in the diagram, the intersection. So the probability of choosing somebody who plays hockey and camogie is 0.2. Next, let's find the probability that somebody plays camogie given that they play hockey. Well, don't forget we've got a formula for this. And in this case, it's the probability that somebody plays camogie and hockey over the probability that somebody just plays hockey. Now we've actually calculated these already, so I simply have to fill in my 2 values from the previous parts of the question. So it's 0.2 over 0.7. I'm probably best off writing this as a fraction, and so the probability of somebody playing camogie, given that they play hockey, is 2 over 7. So this particular question had a bit of context in it, but sometimes you can have questions where there's no context, just a Venn diagram, and you're asked questions on the basis of the diagram. So in questions like this, it's very important that we know our set notation. So it probably wouldn't be a bad plan to pause the video here and write down all the different symbols you can think of in sets and what they mean. So here are 10 questions we're going to answer on this Venn diagram. Again, pause the video here and see how many of these you can do yourself, and then unpause and see if you're correct. So first of all, find the probability of A. That means I want to look at the full A set and get the total of the probabilities in there. So at the moment, 0.3 and 0.1, I'll add these and get 0.4. It's a similar idea for probability of B. I'll add up all the regions within B, in this case 0.1 and 0.4, making 0.5. Next, I've got the probability of A intersection B. That's simply the region where A and B meet, and so in this case that's just 0.1. Probability of A union B is all of A and B together, so I will add up all the regions within A and B. In this case that gives me 0.8. The next question asks me to find the probability of A complement. Now, A complement means everything outside of A. And a nice way to do that visually is to actually hover over the A set, and whatever I can still see makes up my answer. So in this case, 0.2 and 0.4, making 0.6. Next, I have the probability of B complement. Same idea, I want to find what's outside of B. What's the chances of stuff that's outside of B happening? So I'm going to cover over the B set. And my answer will be made up of the regions that are still visible. So in this case, I've got 0.2 and 0.3, making 0.5. The next one's a complement still, probability of A intersection B complement. That means everything outside of A intersection B, so I'll just cover that part, and the regions that I can still see make up my answer. In this case, that's going to be 0.9. In the next one, I want to find the probability of A union B complement. Don't worry, that little dash there is the complement. And so I'm going to cover over all of A union B, and whatever is still visible makes my answer, in this case 0.2. In the next bit, I have to be just a little bit careful about my notation. You'll see here that I've got a line down between the A and the B. This line is coming straight down, so it refers to the probability of one event given another. Don't mix it up, I should say, with set difference, which looks very like it, but is a little bit different. I'll point out why. Set difference will be written as A/B, and the slash will be a backslash. In this case, however, the line is coming straight down, so it's referring to conditional probability. And of course, the minute I see conditional probability, I think of my formula, which in this case would be the probability of A intersection B over the probability of B. Those values are easy to access. A intersection B is 0.1, and the probability of B is 0.5. I can write my answer as 1/5 or 0.2. And finally, the probability of B given A, very similar to the previous question. Again, I want to write the formula down. So in this case, it's the probability of B intersection A over the probability of A. Of course, B intersection A and A intersection B are the same thing. It's just the overlap. So in this case, that should be 0.1 over 0.4, which I can simplify to 1/4 or 0.25.